Not for uh, testing, mean if the population standard deviation is not known. So instead of z-test, we have the t-test. So we still have a very similar formula, but instead of z as sigma, we use s. And we have the degrees of freedom to be n minus 1. And the assumptions are still the same. So first, let's learn how to find critical value. Find the critical t value for alpha of 0.05 with the 16 for a right-tailed test. So, as I told you in our previous topic, the rho for one tail and two tail are not gonna be used when the problem is about confidence interval. But when it comes to hypothesis testing, it's either one tail or two tail, and we have to use these rows. So for alpha of 0.05, and it is right tail test, okay, so we're going to use this row, one tail, because it is right or left. And the alpha is 0.05, and the df is 16, then intersect in order to find the t value, okay? T value. That is 1.746. Okay, more examples. Find the critical t value for alpha of 0.01 df, 22 for left tail. Test the same. So, oi, 22 is not visible here. So in here we have t squared. Yep. Okay. So the t value for alpha 0.01. So this is 0.01 in here. The df is 22. So this is the t value. 2.5008 for degrees of freedom of 22, and for left tail of significance value of 0.01. 2.508. So the t is 2.508. Next, the critical values for alpha of zero point 0.1 and the 18 for two-tailed test. 0.1 and 18. So two-tailed test, 0.1 and 18. This is it. 1.734. 1.734. Maybe we have to use sum. This is alpha. This is just positive for right, negative for left tail, and then alpha or two tail, just to distinguish different t values. And the last, find the critical value for alpha 0.05 with df 28. 0.05 left tail, so 0.05 here, df is 28. 28, oops, no. 28 is two-tailed, wait. Yep, right-tailed. Right-tailed 0.05, yeah, correct. So the answer is 1.701. 1.701. Okay, so that's how you find t-values using the t or student distribution. And please don't forget the sign. So since it is left tail, it should be negative, and this is right tail, this should be positive, and since this is two tail, you have plus minus 1.734. Okay, this is the basic steps of doing hypothesis testing using t-test traditional way. Follow the same procedure as for the z-test, except use table F. Okay. First, of course, identify or state the hypothesis, find the critical values, compute for the test value, the area under curves, make decision based on whether the CV has landed on the critical region or the non-critical region, and then summarize the results for additional step 1. For the p-value, similar steps, state the hypothesis, compute the test value, find the p-value, make the decision by, of course, comparing the p-value and the significance level. Then make decision. So for example, a medical investigation claims that the average number of infections per week at a hospital in southwestern Pennsylvania is 16.3. A random sample of 10 weeks had a mean number of 17.7 infections. The sample standard deviation is 1.8. Is there enough evidence to reject the investigator's claim at 0.05 level of significance? So let's find it out. First, let's state the null hypothesis. So the null hypothesis is that it is equals to 16.3. So for the alternative, a random sample. So there's no specific direction for the number of infections if it is greater than or less than 16.3. So that is unequal to 16.3. So next, we have to compute the z value, I mean the p value, x bar minus u s n, because it is sample standard deviation. 1.8 is s. So this is 17.7 minus 16.3 divided by 1.8 and the sample of 10. So the value of that is 17.7, wait, 17.7 minus 16.3 divided by 1.8 divided by square root of 10. 2.46. Okay, so that is our p value. What about the critical value? Critical value is, of course, can be determined by, first, let's have a drawing of the distribution of the curve at a significance level of 0.05, and it is two-tailed. Therefore, this is 0.025 and this is 0.025 for a total 0.05. Therefore, the half is 0.475. 0.475. Okay. So what's the critical value for that? Critical value for that is 0.475. That's 1.96. So this is 1.96, which is negative 1.96. And since the test value is right here, 2.46 in the critical region, therefore, the conclusion is to reject the null hypothesis. The average number of infections per week in that hospital is not 16.3, but 17.7. Okay, using the traditional method, and the second case that the standard deviation is null. So for the second example, an educator claims that the average salary of substitute teachers in school districts is less than $60 per day. A random sample of 8 school districts is selected and the daily salaries in dollars are shown. question is there enough evidence to support the educator's claim at 10% level of significance? So let's find out. Since we are giving raw data, then we're going to solve for the x bar and the sample standard deviation from variance, which is sum square divided by n minus 1. First, let's state the hypothesis. Null hypothesis, since it is less than, therefore we know that the alternative is less than 60. Therefore, the null is 60. And the alternative is less than 60. So since we are given raw data, it is obvious that we are going to use the p-value, since our standard deviation is sample standard deviation, and it is also uh, stated here that a sample of 8 schools. So you have two clues: sample keyword and the actual raw data. So we have to use the p x value s divided by square root of n. Okay, so I would like to leave this out as an exercise. You can solve for the p. All I can do is uh, give you the critical value. This is left tail, so this is critical value. This is 0.0, 0.1, therefore this is 0.4 critical value. So um, sample size is A, therefore the df is n minus 1, 8 minus 1 is 7. And this is left tail. So we have to look for uh, one tail and 7 degrees of freedom. One tail, just one tail. What is the level of significance? 0.1. So this is 0.1. And the df is 7. So 7. 1.415. So this is negative 1.415. So you compare that to your p-value. If it is to the right or to the left, you decide whether to reject or to accept the null hypothesis. What about using the p-value method? The p-values for the t-test can be found by using table F. However, specific p-values for t-tests cannot be obtained from the table since only selected values of alpha are given. Alright. Okay, so example. Find the p-value when the t-test value is 2.056. The sample size is 11. So the degrees of freedom is simply 10 and the test is right tail. Okay, so if you look at the table F, which is shown in the next slide, the value of 2.056 cannot be found, okay, because the table contains only selected values. So 2.056 falls within this range between 1.812 and 2.228. So at degrees of freedom of 10, and since it is right tailed, therefore we're going to use this row, one tail, and the alpha, and alpha is not given. So yep, no need or no use for alpha because we have the horizontal, which is uh, in one tail. So that's 0.05 and 0.025. So once you intersect these 2 points to this line, we get 1.812 and 2.228. Therefore, the value of p-value is within 0.025 and 0.05. And also the value of t is within 1.812 t at 2.228. So depending on the given of the significance level, you can conclude whether to reject or accept the null hypothesis because the value of the p-value for t, which is 2.056, although it cannot be determined eh, exactly by simply looking at the table, of course you can determine through interpolation. But no need for that because we can still conclude whether to reject or to accept the null hypothesis by simply comparing the value if it falls within certain values of significance level. So hence, the p-value would be contained in the interval of 0.025 and 0.05. This means that the p-value is between. If alpha will were zero point zero 0.05, for instance, you will reject the null hypothesis, depending on the value of alpha. So yeah, that's it. How to use the p-value method. So personally, I would prefer the additional method because it's straightforward and it's easier to convert significance level into critical value and compare it to z-score or t-score than convert the z-score or the t-score or any other scores to the probability value and compare it to the uh, p-value. Okay, so another sample. Find the p-value when the t-test value is 2.983 and the sample size is 6 and the t-test is 2 tailed. So let's do it ourselves using the table F. So we have 2.983 and the sample size is 6, therefore the degrees of freedom is 5. So we have here, and it is 2 tailed. So 2 tailed. So 2 tailed. And the value is 2.983. 2.983, sorry. It's between here and here. Since it is, that is the low for degrees of freedom of 5, and 2.983 is between these values. Therefore, the p-value is between 0.02 and 0.05. 0.02 and 0.05. Uh, the p-value, which is 2.983, is within 3.365 and 2.571. Yep. Yeah. Again, there's no given for alpha or significance level. Depending on the value of the alpha, you can conclude what to do with the hypothesis. So the p-value falls within 2 to 5%. Another example, if physician claims that joggers' maximum volume oxygen uptake is greater than the average of all adults, his sample of 15 joggers has a mean of 40.6 milliliters per kilogram and a standard deviation of 6. If the average of all adults is 36.7, is there enough evidence to support the physician's claim? Let's find out. First things first, the null hypothesis. 40 milligram. Okay, so that's 36.7. 36.7, and the alternative is that greater than 36.7. And based on a sample of 15 joggers, the X bar is 40.6. This is the S. So the T is X bar minus mu S equal to N. So we have X bar of 40.6 minus 36.7 divided by standard deviation of 6 and the sample of 15. So the t value is equivalent to 40.6 minus 36.7 divided by 6 divided by the square root of 15. 2.50, it is 2.52. Okay, so given alpha to be 5%. 2.52, let's look at the table F. 2.52. And it is one tail or two tail? It is one tail. So let's draw it. This is 0.05. This is 0.45. So one tail 2.52. The degrees of freedom is 40. 2.52 is between here. Okay, so it's between 2 and 5. No, it's between 1 and 2.5 because it is one tail. It's 1 and 0.025. So 0.025, 0.01. All right. So since alpha is given, we can still conclude the value p is less than 0.01. It doesn't matter how much it is less than 0.01. Okay, this is enough because zero point zero 0.01 is less than 0.05. Therefore, the p-value falls in the critical region. Therefore, we have to reject the null hypothesis. The average is indeed greater than 36.7. Okay, greater than the average of all adults, the joggers. Okay, when you exercise, of course, and there can be long-term physical changes in you. Okay, so for applying the concepts, I will leave that out to you as an exercise for conceptualization.